if you recall, in the past, we've done linear regressions and quadratic regressions. When we were given points on a graph, we did a regression using our calculator to find the equation of that line or parabola. Turns out that our calculator can also do this for cubic or quartic polynomials as well. And so I've got your steps down here. Hopefully this is very familiar to you. Otherwise, I'll kind of walk you through it real quick. So press Stat, and then select Edit to get to your L1, L2. Now, if those don't pop up, let me know in class. I'll show you how to get those back. If you got stuff in there, just go up to L2 and press Clear to empty your list out. So I've typed in my data already. All my X values are in L1, all my Y values are in L2, and make sure they match up. All right, so pause the video if you need to, but get those values typed in. Once that's done, to actually run the regression, press Stat, and then arrow over to Calculate. Now you'll see the ones we've done before. We've done linear regression, we've done quadratic regression. Here are the new ones we'll work with: cubic, which would be 3rd degree, and quartic, which would be 4th degree. Well, it doesn't tell us which one to use, but I can see that since I have 3 zeros, it's going to be a cubic equation. Some people tell me, well, there's 2 turning points, so that also makes it degree 3. No matter, or they talk about the end behavior. No matter how you want to think about it, it is going to be a cubic equation. So select cubic regression. This screen may pop up, or you may just get something that says press enter. Either way, arrow down to calculator, press enter a few times, and it will do its calculation for you. There's the form this is going to be in, and there's our values. So make sure you actually write out the equation. Don't just put what A, B, C, and D are. Notice that x squared was 0, so I just skipped that term. So there's going to be the cubic equation that's going to hit all those points. Recall that the R value represents the correlation coefficient. If you don't see that number pop up, talk to me in class. I'll show you how to get that, because we will need that for some other examples we're going to take a look at. So let's take a look at a second example. This time, they ask us to write a model that's going to fit this data down here. But the thing is, they don't tell us whether to use quadratic or cubic or quartic or what. And so what we're going to do is we're going to rely on that R value, that correlation coefficient. Remember, the closer we are to 1 or -1, the better the fit it is. So we want to get as close as we can to 1. And that's how we're going to test and see which. So we're just going to guess and check for this. So once again, I've gone ahead and already typed my data in. X is in the L1 column, Y, or the f of x or the Y data is in the L2 column. Pause the video if you need to get that data typed in. And then what I'm going to do is I'm going to guess and check. You want to make sure, though, you start from the lowest power possible. So start with the quadratic regression. Run that one first. Always go quadratic, then cubic, then quartic. Don't go with the reverse order. Go in this order. So select quadratic first, and let's try that regression. So remember, this screen might pop up, or you might get a different screen. Just press enter till it does its regression. There's its equation if we did a quadratic model. And notice our R value, it's 0.9989. That's pretty darn good. Let's see if we can do better than that, though. Remember, if we can get a 1, that's going to be our ideal. Otherwise, we'll get the closest we can to 1. So just make a mental note, or maybe even write it down. 0.9989 is what we got for quadratic. So let's go back and try the cubic regression this time with the same data. Let's see if we can get a better fit if it's a cubic model. So select this one, cubic regression. Again, press enter until it runs the regression. It's going to give us, let's see this time what happens. Hey, look, this time we got an R value, R squared value of 1. As soon as you get an R value of 1, you found the perfect fit. So there's no reason to even try the quartic. I'm going to show you what would happen if you did. But let's use this as our equation then. Remember, A, B, C, D are your values. They're telling you where they go up here. Since D is 0, I just went and left that off of my answer, but there's going to be my best model for this. As far as why I picked cubic, I'd say because the R value was 1. It was the best fit for it. Watch what happens, though, if you did run a quartic regression, or if you did these out of order. I want you to be cautious of this. So let's say you didn't notice that, or if you did them out of order, you did quartic first. So this would give you a 4th degree polynomial. So go ahead and run it. And you may have to scroll up and down because you get a lot of numbers in this list. You also, in this one, get an R squared, an R value of 1. And so some people say, well, this is the perfect fit. But take a look at the values they gave you and ask yourself, does this really represent a quartic regression? Look at the A value. It's 0. So we have 0x to the 4th, meaning that term's not even there. So this isn't even a quartic regression. It is still just cubic. And look, in fact, those are the same numbers we got. So just be cautious of that. All right, and finally, let's take a look at a real-life example of why we can use a cubic or quartic regression. So in this case, we've got a real-life situation where we've got the speed of a rocket ship or space shuttle, I suppose, how many seconds it's after it's been launched. And so once again, I've typed my data in, pause the video and get your data typed in. This time I don't need to guess which model to use. They've just told me to use a cubic model. Otherwise, I could use what we just talked about and run through my different regressions until I find the best fit for it. So at this point, they've said cubic regression, so let's do a cubic regression to find the equation that fits this real-life model as this space shuttle is changing speeds as after it's been launched. So I select cubic, go ahead and press enter till it runs the regression. Now, since it's a real-life problem, your numbers are going to be really nasty. Normally, I say round to 2 decimal places. That A value, though, is so small, I decided to round it to 3 decimal places to be a little more accurate, but typically just to 2 decimal places. So there's going to be my polynomial equation that represents the situation. Well, they've gone ahead and they've asked one more question, though. They said, okay, you found that model, but now use it to make a prediction. I want to know when the rocket ship, the spaceship, is going to be going 4,400 feet per second. Well, notice in your table that's your y value. So my guess is it's going to be off the chart over here. It's going to be above 80 seconds because it seems to be increasing with speed, or the speed is increasing over time. And so what I'm going to do is actually solve this by graphing because they gave me the y value. So let's switch over to y equals. And here's what we need to get typed in. We're going to need to get this equation typed in. We're going to need to get as y2. I want to find an intersection, so I'll type that as y2. I'm going to pause the video so I can type this in without you stalling. So go ahead and pause as well and get your equation typed in. All right, so there's my equation typed in, so I didn't have to waste your time. At this point, before we graph it, remember, we're going to be looking for an intersection. And so my window is going to need to be adjusted. Because I know the line y equals 4,400 is going to be a line, horizontal line, 4,400 space up. So my 10 by 10 windows, no way is going to be good. So let's adjust our window before we graph it. So x is the time in seconds. So 0 makes sense to use as a minimum. As far as the maximum number of seconds, I don't really know. My guess was it was going to be over 80 because the speed is increasing and I want to get all the way to 4,400. So it looks like I had already guessed 200, but that was a total guess. Basically, if you don't see an intersection, you need to guess differently. So either guess bigger or guess lower depending on what you're seeing. So let's use 0 to 200 seconds. Your y value represents the speed. So 0 would be your minimum speed. I know how high I need to go. I need to go at least up to 4,400. To see that line. So I went up to 5,000 so I would know that I saw that for sure. So let's hit graph and see what we can see. So there's the blue line representing the polynomial, which I think I must have graphed wrong. Yep, hang on. Okay, there we go. Sorry about that. Even math teachers make mistakes. I had typed in a negative 0.007 instead of positive 0.007. So sorry about that. So there's the graph that you guys are seeing. Hopefully you typed that in correctly. And so what I want to now find is this intersection point. So hit second trace and select intersect, option 5. And I want to trace over close to it. I'm already there. So press enter 3 times. And this will tell me then the intersection point when the rocket ship is going about 4,400 feet per second should be about 101.24 seconds. So that was my intersection point. So there is my answer, and guess what? That is the very last example problem from semester 1. Hooray! Semester 1 is done.